Chapter 1, Section 8, Digging Deeper, Flow-Related Hazards, Lava. In the Investigate, you explored the effects of temperature, volume channels, and slope on the flows of lava and lahars from volcanoes. Lava flows are streams of molten rock. Let me zoom in a little bit. Lava flows are streams of molten rock that come from vents and fissures in Earth's crust. Lava flows destroy almost everything in their path. However, most lava flows move slowly enough for people to move out of the way. Slope and cooling affect the flow of lava. Lava flows faster on a steeper slope. As lava cools, it flows less and less easily. Lava that is low in silica is less viscous. Flows of low silica lava can travel tens of kilometers from the source. Sometimes it sets up an internal plumbing system. The surface may cool, crust over, and insulate the interior. This keeps the lava at a high temperature as it moves away from the source. Evidence of this is found in the lava tubes that can form in flows of low silica lava. This is shown in Figure 1 when lava breaks out of the leading edge of the flow. The lava can drain out. A hollow tube remains behind. Okay, let me scroll up a little bit. Figure 1. Lava tubes form when the surface of a flow cools and crusts over, but the interior of the flow is still fluid. So see these tubes? This is the fluid interior, and then these are the tubes. Basalt flows can move at speeds of up to 10 kilometers per hour on steep slopes. On a shallow slope, basalt flows move less than 1 kilometer per hour. Basalt flows within channels or lava tubes can travel very fast. They can reach speeds of 45 kilometers per hour. Basalt flows can cover a large area. The largest lava flow in recent history occurred in 1783 at Laki in Iceland. Lava erupted from the Laki fissure, covered 500 kilometers squared. This is an area roughly equal to 100,000 soccer fields. Lava flows can be dangerous and destroy property. The Kilauea volcano in Hawaii started erupting in 1983. Since then, lava flows have entered communities in the area many times. The flows have destroyed homes, highways, and historical sites. The village of Kalapana was buried in 1990 by 15 to 25 meters of lava. These eruptions took place over a period of 7 months. Figure 2. The former village of Kalapana was buried by lava flows. So here's what the village was like before the volcano. Then the lava flowed through, and it destroyed a lot of property. It is sometimes possible to control the flow of lava. In 1973, lava flows at Heimaey, Iceland, threatened to cut off an important harbor. Citizens sprayed water onto the lava from ships in the harbor. This stopped the flow. Lava flows can also be diverted away from populated areas. To do this, structures must be engineered to carve a new channel or pathway for the lava to follow. And andesitic lava is cooler and has higher silica than basaltic lava. It moves only a few kilometers per hour. Andesitic lava rarely flows beyond the base of the volcano. Dacitic and rhyolitic lavas are even higher in silica. They are even more viscous. Their lava usually forms steep mountains called lava domes. These domes extend only short distances from the vent. Pyroclastic flows. Figure 3. Flow of pyroclastic materials from Mount St. Helens destroyed everything in its path. Pyroclastic flows. Topography plays a role in two other types of volcanic flows. It plays a role in pyroclastic flows and lahars. Pyroclastic flows are high-density mixtures of hot ash and rock fragments with hot gases. Pyroclastic flows occur in explosive eruptions. They move away from the vent at speeds of up to 350 kilometers per hour. Pyroclastic flows often have two parts. A lower flow of coarse fragments moves along the ground. A turbulent cloud of ash rises above the lower flow. Both parts ride upon a cushion of air. This enables the material to move rapidly. The more dense material follows topography in a twisting path downslope. The ash falls to the ground downwind of the volcano. Pyroclastic flows are extremely dangerous. They destroy everything in their path. The pyroclastic flow produced by the Mount St. Helens eruption was impressive, but it was small compared to the pyroclastic flows in prehistoric times. A lahar is a wet, cement-like mixture of water, mud, and volcanic rock fragments. This mixture flows down the slopes of the volcano and its river valleys. Lahars carry rock debris of varying sizes. They range from clay to gravel to boulders more than 10 meters in diameter. In Figure 4, the widespread dark-colored deposit on the near side of Mount St. Helens is an example of a lahar flow. Okay, so they're saying the widespread dark-colored deposit on the near side is an example of a lahar flow. Okay. Eruptions may trigger lahars. Heat from the eruption may melt snow and ice, or the eruption may displace water from a mountain, lake, or river. Lahars sometimes form when the erupted material dams the mountain's drainage, causing a lake to form. The lake may spill over the loose volcanic material and send water and debris down the valley. Lahars are also formed when rain soaks the loose volcanic debris during or after an eruption, causing it to start to flow. As a lahar flows downstream, it poses a risk to everyone in the valley downstream. When a lahar finally comes to a stop, it can bury an entire village under many meters of mud. In Alaska, lahars pose a serious threat to coastal terminals and the Alaskan oil pipeline. In Figure 5, a close-up photograph of a lahar deposit showing mud and larger fragments of debris. So here's kind of the mud, and then you can see the larger fragments. Figure 6, a building buried by lahars and floods some 35 kilometers or 22 miles downstream from the 1989-1990 eruption of Redoubt Volcano, Alaska.